Hello everyone, my name is AditiDeshpande and topic for this presentation is different kernel functions in SVM. So let's start. This will be the content throughout our presentation. Next, so first of all we will see what is this SVM. Support vector machine or SVM is one of the popular supervised learning algorithm which is used for classification as well as regression problems. However, primarily it is used for classification problems in machine learning. The goal of the SVM algorithm is to create the best line or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct category in the future. This best decision boundary is called as hyperplane. SVM chooses the extreme points or vectors that helps in creating the hyperplane. These extreme cases are called as support vectors and hence algorithm is termed as support vector machine. The objective of this support vector machine algorithm is to find hyperplane in n-dimensional space that distinctly classifies the data points. To separate the two classes of data points, there are many possible hyperplanes that could be chosen. Our objective is to find a plane that has the maximum margin, that is the maximum distance between the data points of the both classes. Maximizing the margin distance provides some reinforcement so that future data points can be classified with the more confidence. In this, kernels are used to separate it. Next, for a kernel is a function used to helping to solve a problem. They provide shortcuts to avoid complex calculations. The amazing thing about kernel is that we can go to higher dimension and perform smooth calculations with the help of it. We can go up to the infinite number of dimensions using kernels. Sometimes we cannot have a hyperplane for certain problems. This problem arises when we go up to higher dimensions and try to form a hyperplane. A kernel helps to form the hyperplane in higher dimensions without raising the complexity. This is a two-dimensional data. This data is not a linearly separable data set, as you can see in non-linear data and linear data. What we have done is we have transformed this data set to higher dimension so that it will be linearly separable. For this, we have used the function. So the original function is phi of x1 x2 is equals to x1 square root 2 of x1 x2 and x2 square. By applying this function, we will be able to separate our data set linearly. So by taking the example, we will see that first data set is A and second is B. I have shown in this A1, A2, B1, B2. By now, dot product of transformed data. What is transformed data in this case? Phi of A is equal to A1 square root 2 of A1 A2 or A2 square, then phi of B is equal to B1 square root 2 of B1 B2 square. This is the transformed data. We had transformed this data according to this original function. By now dot product of transformed data, at the end of this calculation, you will get to know that transform data dot product can be written in the form of original data dot product. A and B, that is the original data. As you can see here, this is the original data and we can write the transform data dot product in the form of original data dot product. So this is the kernel function. Next, in this diagram, the red and blue balls cannot be separated by a straight line as they are randomly distributed, and this is the reality. How most real life problems data are randomly distributed. In machine learning, a kernel is usually used to refer to the kernel trick, a method of using linear classifiers to solve a non-linear problem. It entails transforming linear inseparable data to linearly separable ones. The kernel function is what is applied to each data instances to map the original non-linear observations into a higher dimensional space in which they become separable. Next is the working of the kernel functions. Kernels are a way to solve non-linear problems with the help of linear classifier. This is known as the kernel trick method. The kernel functions are used as parameters in the SVM codes. They help to determine the shape of the hyperplane and decision boundary. We can set the value of the kernel parameters in the SVM code. The value can be any type of kernel from linear to polynomial. If the value of the kernel is linear, then the decision boundary would be linear and two-dimensional. These kernel functions also help in giving decision boundaries for higher dimensions. We do not need to do complex calculation. The kernel function do all the hard work. We just have to give the input and uses the appropriate kernel. Also, we can solve the overfitting problem in SVM using the kernel functions. Overfitting happens when there are more feature sets than sample sets in the data. We can solve the problem by either increasing the data or by choosing the right kernel. There are kernels like RBF that works well with smaller data as well, but RBF is a universal kernel and using it on a smaller data set might increase the chances of overfitting. Hence, the use of simpler kernels like linear and polynomial is encouraged. Next, different kernel functions. So first is the linear function. It is the most basic type of kernel, usually one-dimensional in nature. It proves to be the best function when there are lots of features. The linear kernel is most preferred for text classification problems. The linear kernel is mostly preferred for text classification problems, as most of these kinds of classification problems can be linearly separated. Linear kernel functions are faster than other functions. Next is the polynomial kernel. It is popular in image processing. It is more generalized representation of linear kernel. It is not as preferred as other kernel functions as it is less efficient and accurate. Next is Gaussian radial basis function, that is RBF. It is one of the most preferred and used kernel function in SVM. It is usually chosen for nonlinear data. It helps to make proper separation when there is no prior knowledge of data. When there is no prior knowledge about the data, Gaussian radial function is used. Next is the sigmoid kernel. It is used mostly preferred for neural networks. This kernel function is similar to a two-layer model of the neural network, which works as an activation function for neurons. Next is Bessel function of the first kind kernel. We can use it to remove the cross term in the mathematical function. ANOVA radial basis kernel, we can use it in a regression problems. Next is the implementation. I will show it in Python. First of all, we will see the linear kernel. I have implemented this by using iris dataset, importing these libraries, then importing the same data from the iris dataset, and here SVM kernel is equals to linear kernel importing and plotting the graph. As you can see that by just a straight line, they have separated this sepal width and sepal length, data points for sepal width and data points for sepal length. Next is the RBF kernel. Same with the RBF kernel. Importing the libraries and iris dataset, I have used same dataset, and you can see that here it is also separating out. Same for the polynomial and same for the sigmoid. separating this sepal width and sepal length. Next, so this is about the implementation. Then advantages of the kernel function. Kernel functions are used in many applications, provide a simple bridge between linearity and non-linearity for algorithms. We do not need to do complex calculation. The kernel function do all the hard work, and you can specify different kernel functions to make a proper decision boundary. Next is the disadvantages of kernel function. You have to choose appropriate kernel function, and it's not easy to identify which is appropriate for the which application. So the choosing the wrong kernel function gives you the wrong output. Applications. These kernel functions, SVM kernel functions, have the vast applications because the linear kernel is mostly preferred for the text classification problems as it performs well for large dataset. Then Gaussian kernels tends to give a good results when there is no additional information regarding data that is not available or unseen data. RBF kernel is also kind of Gaussian kernel which projects the high dimensional data and then researches a linear separation for it. Polynomial kernels gives good results for problems where all the training data is normalized. Conclusion. In this assignment of my topic was different kernel functions in the SVM. I have implemented different kernel functions in SVM in Python and learned important concepts of SVM kernel functions in detail. These are the some references. Thank you.